Alright, today we're going to be talking about polynomials and linear factors and how factors relate to our polynomials and all that fun stuff here. So given that you have some type of polynomial with a bunch of different, degree terms here, we're going to say x minus b. We're going to call this in this format right here, usually inside of parentheses, we're going to say that this is a factor. And if x minus b is a factor, then we're going to say b, which is the opposite sign, notice. B is going to be either a solution, a root, or an x-intercept of your graph right there. Solution, root, x-intercept. There's actually, you could even add this here. You could even say it's a 0. Okay, so anything that any of these factors here would be, kind of like the x-intercepts of your graph, and we'll look at a graph here, an example, or in a minute here as an example. So we're going to write this in factor form. So what we need to do here, this actually kind of ties into the 8.4 lesson here. If you if you've already watched that and looked at all the factor and stuff, you can do all that. But anyways, if not, no big deal. Here, what we're going to do is divide everything here by x. And if we do that, we're going to have x squared minus 2x and then minus 15 left. And then we're going to factor the leftover stuff right here. That's in parentheses right there. So I need to figure out what times what gives me x squared. We can put x and x. And then what times what gives me negative 15. That adds up to that negative 2 right there. So that should be, I guess, a negative 5 and then minus 3. Or actually, I'm sorry, positive 3 right there. Okay, and then this is your equation right there. This is in factored form right there. But then it says find the zeros. To find the zeros, you literally plug in 0 for the left side. And then once you're done with that, then you set your factors, which are these pieces here. You set them equal to 0. So either x equals 0, x equals positive 5, and then x equals negative 3. Alright, so these are your x-intercepts, or you can say solutions or zeros, whatever you want to put there. And then these are your factors. And really, I guess the whole idea of today is knowing the difference between factors and then your zeros. So that's all we're going to do there on that one. So this next one here, we're going to go backwards. We're going to start with zeros, and then we're going to write a polynomial function in standard form with these given zeros. So notice you got negative 2, positive 2, and 3. So if you want to write the 0 for negative 2, we do the opposite sign. So usually it's, x minus the b value, or whatever your 0 is. So if we do x minus negative 2, it's going to look like this, x minus negative 2 right there, which we go and change to a plus. All right, if we do this next one here, this is going to be x and then minus 2 for that one there. So it's the opposite sign. And then this last factor, we're going to write as x minus 3. So if I want to write a function with all of those, you'll write x plus 2, x minus 2, and then x plus 3. All right. Now, since I asked for the equation in standard form, that means I need to simplify everything down. So that means I need to FOIL 2 of these together and then multiply by x plus 3 afterwards. So I'm going to go ahead and FOIL 2 of these together. I'm going to go x plus 2 and then x minus 2 first. It's going to give me x squared. That's going to be negative 2x, positive 2x, and then minus 4 right there. And then when I simplify that, the 2x's actually cancel out, so you're left with x squared and then minus 4. Now you still got x plus 3 that you actually have to multiply by this by. And since that's two binomials, that's another FOIL problem. So we're going to go all of those. X squared times x is x cubed. X squared times 3 is 3x squared. You got negative 4 times x, that's negative 4x. And then finally you got negative 4 times 3, that'll be negative 12. And then actually you can't simplify this, so this is your polynomial function right here. This is all done right there. That's taking zeros and making a polynomial function that goes through them all. Now, since you can have different things going on as far as vertical stretches and shrinks, you can actually multiply by an a value in this case, but they don't ask for that, so we don't need to do that in this case. But I think here in a minute we'll see an example where we do need to do that. Okay, finding the multiplicity of a zero. So this graph right here, find the zeros. What are the multiplicities of the zeros? How does a graph behave at those zeros there? So that's kind of weird, multiplicity of zeros. So let's see what they're talking about here. What we do to go find this, first of all, is you're going to factor as much as you can, and it looks like everything's divisible by x squared. So I'm going to factor out an x squared. I'm going to be left with x squared minus 2x and then minus 8. And then from here, we need to factor the leftover trinomial. So what multiplies the x squared is x and x. And what multiplies the negative 8, that'll be negative 4 and then positive 2. And that is your function there. Okay, so if you look at your zeros, you're going to say x squared equals 0, so x therefore equals 0. You're going to say x minus 4 equals 0, so x equals positive 4. And then x plus 2 equals 0, so x equals negative 2. And then what we're going to do here is I'm going to describe what multiplicity is by using a graphing calculator. So I'm going to go type this exact equation in. I'm going to type it in the factor form, but you can type in the original as well. They're technically the same. So whatever you got going on there, you can clear it out. So we have x squared, and then we have parentheses x minus 4. And then parentheses x plus 2. And then we're going to graph. There you go. So what's going on with this graph here is notice it crosses through negative 2, and then it also crosses through positive 4. Those are two of our zeros. And then it touches right here at 0. And that's because x squared, we had in our equation, let's see if I can pull it up here, we had x squared equals 0. And that means two of our solutions is actually 0 in this case. And if you have two of your zeros, is the number 0 here, that means it's going to bounce off and then just touch it and then go back the other way. It's like it has to go through 0 twice, and the only way it can do that is if it actually just touches it and then it goes back the other way. So we say that x equals 0 has a multiplicity of 2. So let's write that. So this has a multiplicity of 2 right there. And then the rest of these here have a multiplicity of 1, which means they only happen one time. So these two individually happen once, and then this last one here, since it was x squared equals 0, means it bounces off of the graph right there. It has a multiplicity of 2. Okay, and then that's actually going to be helpful when writing a polynomial function for this one right here. So notice here on this graph right here, notice that you have a couple of zeros here. You got right there. That looks like at negative 2, at negative 1, and then at 1 right there, it touches twice. Okay, so as far as your zeros and your factors here, you're going to write that the, I guess you're going to write that's your zeros. Let's write this here. Let's go zeros happened at negative 2, 1, or I'm sorry, negative 1, and then 1 twice there, since it bounces off of the graph right there. Okay, then we're going to write these in factored form. So I'm going to write x plus 2, x plus 1, and then x minus 1, and then x minus 1 again, right there. Okay, and then those are all of your factors. So technically, we can write a polynomial function. We go fx right here. That's a function right there. And that function right there would cross all of those points. Now, the only thing that's different about this problem here is you do have a y-intercept, which affects, how tall and stuff, how far these graphs go. So what we're going to do here, we don't know our vertical stretch, so I'm going to put a blank a value out there in front. And this is kind of like what we did with quadratics a while back, except this time we got a bunch of factors. And then what we're going to do is we're going to take this point 0, 4. We're going to call that our x comma y, and then we're going to plug in 0, 4 in for the equation. And remember, fx, this is kind of like saying y right here. So I'm going to plug in 4 over there on that side, and then we're going to have a, and then 0 for every single x that you have right here. So the first one is 0 plus 2. A lot of you guys are going to simplify that in your head right away as your first step, and that's fine if you do. But I'm going to write it out here for our notes. Okay, so you got all that stuff there, and then so this is 2 times 1 times -1 times -1. All right, and then you still have a out in front, so I'll put that there. And then 2 times 1 is 2, -1 times -1 is +1, 2 times +1 is 2. So this will be 2a is equal to 4, and then therefore a is equal to 2. Okay, and then since a is equal to 2, now we can write our function all together. So this will be fx, this will be 2 out in front of the parentheses, and then x plus 2, x plus 1, and then x minus 1 and x minus 1. Or you can even write x minus 1 squared. Whoops, you don't write squared in. Sorry, my bad there on that. So you can either write this thing squared and then not write that x minus 1, or you can just write it out twice. Now, since they asked for the equation in standard form, I actually have to simplify this all the way down. Okay, so I'm actually going to multiply these two together first, and this will make our life easier because those are conjugates, and those are going to simplify with each other here. X times x is x squared, and then you're going to have minus 1x plus 1x, and then minus 1. And that's actually going to simplify down to x squared minus 1. Okay. And then you still got all this other stuff here. I think I'm going to FOIL together, I guess the first and last, or the middle and the last one here. It's my next step. So first outer inner last, this will be x cubed minus x squared, or 1x squared. And then we'll go -1 times x is -x, or -1x, doesn't matter how you write it. And then -1 times -1 would be +1. And then last but not least here, we got to do x plus 2 times everything. And I'm going to see if I can drag this down here a little bit. Give myself some room. So this last step here, kind of a longer problem here. Distribute x to everything. So that'll be x to the 4th. That'll be minus x cubed. This will be minus x squared. And then this will be plus x. And then 2 times everything. This will be 2x cubed. This will be negative 2x squared. Negative 2x. And then finally plus 2 here at the end. And then we're going to combine all of our like terms that we can. So you have x to the 4th. Your x cubes, when you add those together, that's going to get you positive 1x cubed. We got negative x squared and negative 2x squared. That's negative 3x squared. You're going to do x and negative 2x. That'll be negative x. And then finally a 2 at the end. All right. Believe it or not, we're almost done. We're technically not done because we have this 2 out here to begin with. So then for the final thing, we're just going to distribute 2. And then finally, we have this polynomial in standard form. So this will be 2x to the 4th. This will be 2x cubed. This will be negative 6x squared, negative 2x, and then positive 4. And then there's your polynomial. Now sometimes they're not going to tell you to put it in standard form. If they don't tell you to put it in standard form, I would not do all this. I would leave your answer just like this right here. If they say no standard form required, or if they don't even mention it, leave it like this up here at the top. And then if they do say standard form and simplify, then it's got to look like this down here at the bottom. So just be on the lookout there for those and the wording that they give you. Okay. Last example that we're going to do, it's kind of short today, not super long here. We're going to graph this equation here and find the nicest points we can plot. plot those points, and then we're going to write out, I guess we're going to factor it, we're going to do x and y intercepts, and then the relative max and min. We'll talk about each of those pieces. First of all, I do want to factor. If you actually skip ahead and watch the 8.4 lesson, we talk a lot about factor by grouping, which is what I'm going to do here. So if you haven't seen that one yet, go check it out. We are going to divide the first group here. You can divide everything by 2x squared. If you do that, you're left with just x and then plus and then 4. The second group we can factor out at 2. So then that'll be x and then plus 4 as well. And then since your x plus 4 is common, you're going to bring that out. And then the second group here is just going to be negative 2x squared and then I guess plus 2. We can technically factor out a 2 there. And actually we can factor out a negative 2. I'm going to factor out a negative 2, and here's why. If you factor out negative 2, then you have x squared and then minus 1, kind of like that. And then x squared minus 1, we can actually do a difference of squares there. And then write that as x minus 1 and x plus 1. Okay, and then you still have the x plus 4 out there. So those are all of your factors right there. This would be the same function in factored form. So as far as the factors, I'd say x minus 1, x plus 1, and x plus 4. So that means your x-intercepts are the opposite signs. The x-intercepts are 1, negative 1, and then negative 4. And then if your teachers are picky on the notation, you can say your x-intercepts are 1, 0, negative 1, 0, and then negative 4, 0. So we can get that all from there. Everything else, like the y-intercept, well, actually y-intercept, if you just plug in 0 for each of these here, and then you just have 8 left over. So your y-intercept is actually 8. But we would also have a graphing calculator for this. So we're going to actually switch to our graphing calculator and then find the max and min and all that stuff and get a nice plot. So let me clear this out here. This time I'm just going to go ahead and type in the original function in standard form. Doesn't matter what form that you put it in. So just to emphasize that you can do either way, we're going with standard form this time. And then plus 8. And then hopefully all of the stuff that we've talked about so far matches. Apparently we have an x-intercept at, oh, did I do something wrong here? Oh, yeah, if you look here closely, I did cubed, or I did squared instead of cubed. Right there. So right away I knew my first x-intercept should have been at negative 1. It wasn't at negative 1. Let's see if this matches better. Or actually, yeah, I forgot, negative 4. So you have an x-intercept, negative 4, negative 1, positive 1, and it looks like our y-intercept is there at 8. Right there. So that all matches here so far, which is nice. I'm going to go ahead and copy over a couple of nice points onto my graph. Yeah, let's see if I can find any. It's not going to be a ton here. There we go. So apparently we got negative 4, 0. And then here I'm actually going to pull up what I'm doing here. See if y'all can see that. So negative 4, 0. Negative 3, negative 16. So like way down off the graph. You got negative 2, negative 12. You know, maybe kind of like right there. We got negative 1, 0. We got 0, 8. We got 1, 0. And then it goes down way after that. So something that kind of looks like this right here. And then coming back up. And coming back down. Okay. Now there's two other things that we're going to talk about here is how to find the relative max and mins of the graphs right here, or where the max and mins, where it turns, is going to be at here. Oh, sorry. And then so we use our graphing calculator for this here. And if we're looking at the graph now, we can't see where this little minimum point is. So actually I'm going to zoom out just a hair. So I'm just going to hit zoom out. You hit zoom and then zoom out, and then we'll zoom out like that. There you go. So there's your graph right there. There's the minimum. This is called the relative minimum right here at this point, and then this is the relative maximum. To go and find that, we use the max and min buttons on our calculator. So if I want to find the relative minimum first, and it doesn't matter which one you choose, go get the little blinky guy right here. Get him as close as you can to that minimum point. And then I want you to go a couple clicks to the left of that, and then a couple of the clicks to the right of that minimum. And then our calculator is going to look there. Oh, I must have did something wrong here. So second, I don't think my command went through. Minimum. So go to the left, hit enter. There we go. Go to the right, hit enter, and then enter one more time. And that minimum point there apparently is at negative, and I'm going to write this here and I'll put it up on the screen in a second, negative 2.7. Let's go 7.9 right there, and then comma negative 16.4. Let's go, yeah, 16.42. That's your min. And I wrote that here on the screen there. So, all right, and then to find the relative maximum, we'll do the same thing. Second trace, go to maximum this time. And then I want you to get it as close as you can to the maximum. And then go to the left, a couple clicks, hit enter. Go to the right, a couple clicks, hit enter. Enter one more time. And, you know, it looked at initially like our maximum was at 0.8, but it's a hair off of that. So it's apparently at 1.1, or I'm sorry, 0.1, we'll say 0.12. So 0.12 and then 8.12. And that would be the relative maximum, or the maximum of that turning point right there. And that's what you need to copy down. So there you go. Let's see if we need anything else. We don't. So yeah, I believe that is it here for your lesson today.